Bismillah Rahman Rahim. Assalamu alaikum dear students. I'm Arif and I welcome you all in today's session. Well, to access the notebook for today's session, you can access course page on my personal website arifpat.me. You can click the appropriate link under the lecture resource column to view it in NB Viewer and run it online in Binder. The other way is to download it from the course GitHub account Arif PUCIT, and all the notebooks for this course are housed in the public data science repository. Well, this is the Jupyter notebook dashboard running locally on my machine at port 8888, and here is the notebook for today's session, lecture number 3.9 of the third module, Python Programming for Data Scientists, for the course titled Tools and Techniques for Data Science. Well, my dear students, Pandas is an open source Python library built on top of NumPy and provides easy to use data structures and data analysis tools. Pandas has derived its name from Panel Data System and was developed by Wes McKinney in 2008. Well, data scientists use Pandas for performing various data science tasks, starting from downloading, opening, reading, and writing files of different file formats like CSV, Excel, JSON, HTML, and so on. They load the dataset into its data structure called data frame. And a data frame is a two-dimensional labeled data structure like the SQL table with heterogeneously typed columns having both a row and a column index. Well, after the data is loaded in a data frame, data scientists perform various data manipulation tasks like filtering and modifying data based on multiple conditions, cutting, splitting, merging, sorting, scaling, pivoting, and aggregating of data. Well, this data cleaning is done to enhance the data accuracy and integrity by identifying and removing null values, duplicates, and outliers. This data wrangling actually transforms the data structurally to appropriate format and makes it ready to be used by the machine learning engineers so that they can apply appropriate machine learning models on that dataset for training, validating, and testing purposes. My dear students, and this is what we are going to learn in this sub-module of Pandas. And today is the first session of the Pandas series of lectures. And here is the learning agenda of this notebook. The main objective of today's session is just to give you an overview of use of Pandas data frame. I will relate it to Python dictionary for your understanding before finally describing the anatomy of a data frame. And in the bonus part today, I will tell you how you can change some of the display properties of a data frame object. Okay, so first of all, remember that Pandas is not a built-in module of Python, so you have to download and install it. Okay, right now the Pandas version with me is 1.3.4. Today I will keep things extra simple. However, we will inshallah do scuba diving in upcoming sessions. Let me use Pandas read underscore CSV method to load this CSV file Titanic 3.csv into our data frame and I have named the data frame as df underscore Titanic. Well, you can download this CSV file from my GitHub data science repository, whose link is mentioned in the description box below, or you can download it from kaggle.com as well. Let me run the code of this file. Great. So this is what a data frame is. A 2D labeled data structure, just like an SQL table, with columns and rows, the rows having integer indices and the columns identified by labels. Well, my dear students, this is uh, Titanic Dataset. It has 1310 rows with 14 columns containing information about passengers of the Titanic ship that sank in North Atlantic Ocean in 1912 after striking with an iceberg. And these are the various characteristics of the passengers over there. The passenger class, first, second, and third. The survived passengers. 1 means survived, 0 means died. Their name, sex, age, number of siblings and spouses on board, the number of parents and children aboard, the ticket number, the fare, and probably this fare is in British pound, and that too pre 1970, I think. The cabin in which they are residing, the location from where they have embarked. This S means Southampton, and this C probably means Cherbourg, and there might be Q as well over here, which stands for Queenstown, the board, body, and their home destination. So these are all the information about this dataset, and this is normally the first problem that machine learning students normally perform, in which they answer questions like what sort of people were more likely to survive in the Titanic sinking by applying some predictive model. Anyway, let me show you another dataset of your interest now. So this is the IMDB.csv file, Internet Movie Database containing movie ratings. My dear students, all IMDB registered users can cast a vote on every released title. Let me run it, and this is a subset of that, 979 rows, 6 columns. Using different methods of Pandas data frame, we can answer a lot of questions from this dataset, like movies of a specific actor, the list of comedy movies or crime movies, movies that are not for children, movies with runtime of, let's suppose, 2 hours or more. Release years are not mentioned over here. If they are there in the data, we can ask questions related to the release year or release time as well. Our discussion about the dataset will remain incomplete if I will not talk about the COVID-19 disease dataset. Well, this COVID data.csv, this data is collected by WHO and contains daily updates on different statistics of the disease in different countries all around the globe. Once again, I have used read CSV to read the data inside this file into a Panda data frame, which I have named df underscore COVID. Let me execute the code of this cell. Okay. So this is a huge data set having 1.5 lakh rows with 67 columns. Great. My dear students, I think now you have an idea of Pandas data frame, which is a data structure capable of loading this huge amount of data inside the computer memory and allows you to wrangle and clean this data, perform different data analytics, and finally design and train machine learning models to do prediction and forecasting. But to do all this, we have to start from somewhere. and that somewhere is that we need to understand the anatomy of this data frame. So let me start with a simple dictionary. Uh, this is a very simple dictionary, named person, and contains five different attributes: name, age, address, cell, and blood group. The name is the key, and Arif is the corresponding value. The age is the key, and 51 is the corresponding value. So let me run this code. So this is the dictionary. Great. Let us see another dictionary now. This dictionary is named as people. This also contains the same five attributes: name, age, address, cell, and blood group. But this time of six different people, six different persons. Note the key of the dictionary are same. However, the values now are actually a list of data related to six different persons, six different names, six different ages, six different addresses, and so on. Let me execute the code of this cell now. So this is the dictionary. Now let me show you a CSV file, people.csv, and this file also contains the same data as we have seen in this dictionary: the name, age, address, cell phone, and blood group. And under the headings we have six rows. This is the first row containing record of Mr. Rauf. This is the second row containing record of Mr. Arif, and so on. My dear students, let me read this CSV file inside a Pandas data frame, and let me name that data frame df_people. Remember, this people.csv file is there in my disk. You can always download it from the GitHub account. Well, great. So this is how this data frame looks like once it loads the data inside this CSV file. So this is the key, name, and this is the first value, second value, third value, and so on. Please relate it with this dictionary. The name is the key and these are the values. And over here, the key has gone above at the column name and these are the values. So this is what a data frame is. Remember, every row has an associated index which is integer right now, and every column has an associated index that is a label. We can have numbers over here as well. Okay, so let me access the elements. Once we access the element of our dictionary, remember this people is our dictionary and the name is the key. Once I access it, I get a list. Let me confirm this by using the type function. So this is a list which this dictionary has returned. Once I have passed this dictionary a key, so it has returned all the corresponding values related with this key. Let me access the element of a data frame. So this is the name of the data frame and this is the name of the column. Once I run this, I again get the same values, but this time it is not a list, it is a series object. You see, this is a series object. And with every series object, you can note we have the indices over here as well. Okay, so with this intro, let me describe the anatomy of our data frame now. Okay. My dear students, once again, a data frame is a 2D labeled data structure. Labeled. Note the column labels: name, age, address, cell, blood group. In this case, they are strings, while the Row labels are 0, 1, 2, 3, 4, 5. They are numbers, and this can be vice versa as well. Also note that the columns can be of heterogeneous types. Over here, this name column is of string type, while the age column is of integer type. And we can also have date time data in this data frame. Also note that each column of this data frame is actually a series object. So this age column is a series object. This address column is a series object. My dear students, since our data frame is 2D, so we have two axes. Axis 0 is the vertical axis that moves from top to bottom, and we have records or rows along this axis. Similarly, this axis 1 is the horizontal axis that moves from left to right, and the columns changes as we move from left to right. And this is the same concept that we have discussed in the NumPy 2D arrays as well. And at the intersection of each row and column, we have a data value. My dear students, this is from where we will inshallah start our next session. And at the end, let me give you a bonus part in which I will tell you as how we can change the display properties of a data frame object. Let me run this df-covid and show you. This is the data frame of having a lot of rows and a lot of columns, 67 columns. But we see only 20 columns over here. These are 20 columns. You can see an ellipsis over here. 10 columns are on the left of this ellipsis and 10 columns are on the right of this ellipsis. So this is just to keep your data frame inside the display area of your screen. If you want to change this, you need to change the display properties. Let's check out. So we have a method of the Pandas data frame, get underscore option, using which you can check out the values, the default values of different data frames. So let me check out the default values of maximum columns. It is 20, as I have said before. Let me change it to 50 because it has 67 columns. Let me change it to 67 so that I can watch all the columns in one go. And corresponding to get option, we have the set option method. Let me run it. And now let me run this df-covid, and you can see now there is no ellipses in between and all the 67 columns are being displayed. All the 67 columns. Great. My dear students, similarly you can change other properties as well. For example, max rows, you can always change the max rows as well. If you want to change the number of characters to be displayed in each column, let me show you the example of this IMDB Dataset. Over here inside the actors list, you can see this ellipsis over here because it contains characters more than 50. So only first 50 characters are shown over here, and then after that we have this ellipsis. If I want to view more than 50 characters in a specific column, I can change this attribute, max call width of the display. Let me set it to, let's suppose 200. Let me check the default first using the get option. Let me set it to 200 now, and let me run this data frame again. You see there is no ellipses over here now. So the names are complete over here. Great. And of course, once you are done with this, if you want to reset the options back to the normal or default, you can run this reset options and pass it this argument all. Don't worry much about this warning. This is just a deprecation warning about one of the options which is not going to be supported in the future version of Python. Okay, so last thing, my dear students, you can always apply CSS to Pandas data frame. Okay, so if you are comfortable with CSS, then it's fine. If not, let me tell you quickly what this is doing. So you note the table header. I'm changing the background color and font family. You can see it has gone to a different color, the table data, the odd and the even rows are shown in different colors. And finally, this hover property, when I hover on this dataset, it changes its color to something different. So this is really fun to have a good view of the Pandas data frame, which you are going to keep looking and keep looking and keep looking in our upcoming sessions, so that you can get something useful out of it. Great. Uh, my dear students, that is all for today's session. We will, inshallah, continue our journey to learn Python programming for data scientists in our next session. And we will formally start with the next session of Pandas, in which we will learn the depth of the series data structure of the Pandas library. I hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best. Happy learning and Allah Hafiz.